Well, there are so many different types of functions. There's linear functions, that means they're straight lines. There's curvilinear functions, there's exponential functions, logarithmic functions, inverse functions, trig functions. All these functions are based upon, or named based upon how they look. So the first several examples, we're going to review graphing linear functions here. It doesn't say the word linear, but all of them are going to have some sort of straight line to it. And we've referred that to as a linear function. So once again, here is our function, but notice it doesn't have that function notation, such as f of x equals 6 minus x. Notice it has a y instead of the f of x. And so that's okay. You want to start to think about the f of x as the y value. Because if you think about f of x being the y value, then we're going to have some coordinates. And a coordinate is x comma y. So even though it's not next to each other here, they're written in a slightly different format. The x is on top of the y. Think about this being a coordinate as 1 comma 5. This would be the coordinate 3 comma 3. This would be the coordinate what? 5 comma 1. And so how are we getting these numbers? Well, we're just randomly picking domain values, that is the x, and we're plugging it into our function. And so like we said before, this is our rule. So 6 minus 1 would be 5. 6 minus 3 would be 3. 6 minus 5 would give us 1. And notice we're getting these graphical points here, and if we went to graph these points, 1, 5, 3, 3, and 5, 1, and we connected them, we're getting a pattern. And what's the pattern? Well, we're getting a straight line, and that's what we refer to as a linear function. So once again, we're taking this function, we're plugging in points, x values, those are our domain values, and we're getting out y values, that's our range values. And then we just graph them like we did before, and then we get a straight line. Let's do a few examples in here. Here's our next one here. Here is our function. Now it's not written in function format. That would be f of x equals x plus 1. But it's asking us right now to plug in these values. If I plug in 1, that's easy. I get out a 2. If I plug in a 2 and I add 1 to it, I get a 3. If I plug in a 3, I get a 4. If I plug in a 4, I get a 5. 5 gives me a 6. So let's graph all these coordinates. So this would be our first coordinate here, 1 comma 2. Where's 1 comma 2? 1, 2 would be a dot right there. The next one is 2, 3. The next one is 3, 4. Next one's 4, 5. Next one is 5 comma 6. And notice if I connected all these, I would get a straight line. Now that line actually goes on forever. Why? Is because we can plug in any x values we want. Positive, negative, decimals, fractions, it doesn't matter. And if I plugged in really, really big ones, it would go way up to the right. If I plugged in really, really small ones, or even negative numbers, it would go way down to the left. Let's try another one. Here is a different function. This one is a different rule altogether. This is saying take 2 and divide it by whatever x is. So notice they're still telling us what x could be and what x can't be, but really x could be anything. They're just guiding us along here and saying, hey look, try these 5 numbers. So if x is 1, 2 divided by 1 is 2. 2 divided by 2 is 1. 2 divided by 3 is 2/3. 2 divided by 4 is 1/2. And 2 divided by 5 is 2/5. So let's graph all these points in here. There are 5 coordinates in here. The first coordinate is 1, 2. Go over 1, up 2. I go over 2 and up 1. Over 2 and up 1. The next one is over 3. Over 3 and only up 2/3. Over 3. Did we make a mistake in here? No, I don't think so. I'm sorry for the delay in here. I was thinking this is going to be a linear function. This one's not a linear function. This is going to be, well, it's going to be a variation of an exponential function. And so the next one is I go over 3 and up only 2/3. Where's 2/3? Well, it's going to be right over there. The next one is I plug in 4 and I only get a half. The next one I plug in 5 and I get a very small number in here. So if I did this with a little bit more accuracy in here, notice, whoops, notice we're getting some sort of curve in here. And this curve would actually go like this if I graph some more points in here. And that would be an example of an exponential function. We'll do more of those later on. But this is an example I was trying to get you to used to. Though, look, it's not always just a straight line. The first one was a linear function. This one's an exponential function. You may not have to know why it's an exponential function right now or to be able to recognize it's one. But notice it has a nice curved shape in here, and that is an exponential function. And so let's do one more. This is going to be a linear function, I promise. And so this one is saying, once again, plug in 1. When I plug in 1, that's 1/2 plus 2. So that would be 2.5. Okay. The next one is take 2 and plug it into here. 2 divided by 2 is 1, plus 2 is 3. The next one says plug in 3. When I plug in 3, 3 divided by 2 is 1.5, plus 2 is 3.5. Does anyone notice a pattern here with these y values? Every time I go up by 1 here, I'm only going up by a half all over here. And so that is a nice steady pattern. And notice each and every single time it's going up by a half is because of that number right there is the slope. The slope is 1/2. And so when I go to graph this, let's graph a few points in here. When I go over 1, I go up 2.5. When I go over 3, when I go over 2, I go up to 3. And when I go over to 3, I go up to 3.5. When I go over to 4, it's at 4. And when I go over to 5, it's 4.5. And notice that's producing a nice straight line in here. And the slope of that line is 1/2. That means I rise 1 and I run 2. So I think you're ready for all of section 2. It's really tackling the visual aspects of functions. Functions, we enter domain values, that's our x values, and out pops the range, that's our y values. And we get the graph from them. We get the graph from them, we get to see some different pictures in here. All right? Good luck with sections 1 and 2.